Okay, this is Notes 3.3 Part 2. I'm going to skip this and go back to it in just a second. And I want you to recall this graph here. And let's talk about vaporization. Okay, let's talk about vaporization. In other words, this boiling point here. This boiling point of water, which is at 100 degrees Celsius. Okay, all the heat of vaporization is the energy required to boil 1 gram of H2O of water and turn it into gas. So a gram of water turned into a gram of liquid water turned into a gram of gaseous water. That's all vaporization is. That's the heat of vaporization. Okay, and again, we're adding energy. So if we follow this curve now, we're adding energy, boiling this thing. As we're boiling, more of this water is turning into gas. Okay, so we're adding energy into this in order to get it to turn into gas. So for that reason, this heat, this change in heat, is called positive delta H of vaporization. It's positive. Okay, so let's go ahead and write out the units are joules per grams. Joules per grams, because again, it's 1 gram of H2O to turn it into gas. How many joules is required? So our units are joules per grams. The vaporization, the chemical formula is going to look like this. H2O, liquid, that's an L, turns into H2O, gas, that's a G. Okay. Now, which side of this arrow do we put heat on to vaporize it? Well, we're adding heat to the liquid, right? So heat. Okay, we're adding heat to the liquid. And our delta H in this case, we're adding, so we're going to call it this. Well, we'll just say when you do these problems, you're going to use the delta H, and we're adding heat, so it's going to be positive delta H of vaporization. Remember, there is no delta H of condensation. Delta H of condensation doesn't exist. It's just the negative delta H of vaporization, as you're about to see. Let's look at condensation, shall we? Again, condensation is this. We got H2O liquid. H2O gas turns to H2O liquid, right? On which side do we put heat? On which side do we put heat? Well, if we're going from gas to liquid, we're not adding heat to gas, are we? If we're adding heat to gas, we just get gas. So we're losing this heat. We're losing this heat. So that's going to be plus heat over on this side. Okay? And if you have trouble remembering, you can follow this thing back there. Okay? So if you're going from steam or water vapor into liquid, you're going to lose energy, right? You're losing energy. So if you're losing energy, that's going to be condensation, right? You're losing energy. Okay, you're losing energy. You can put that over here like such. Okay, so what delta H do we use? Because we're losing energy, we're going to use a negative delta H. So use negative delta H of vaporization. The negative delta H of vaporization. And what is the delta H of vaporization? The delta H of vaporization for water, now all different substances have their own different delta H's, but the delta H of vaporization for water there, is 2260 joules per gram. That's for water. Delta H vaporization of H2O. Okay? Yeah, so you might see methanol. Every now and again you'll see methanol, or you'll see ethanol, or some kind of alcohol, and they have different delta H's of vaporization, right? but for water, it's 22.60. So if I was going to do a problem that asks me how much energy was used to boil off 1 gram of water into 1 gram of steam, I'm going to use this formula right here, and it's going to be positive. Now, what if it said 1 gram of steam turns into 1 gram of boiling water? Well, then I'm going to use the negative value of that. Now, this same principle also applies for freezing and melting. Okay, so at 0 degrees Celsius, we know that water freezes, but we also, maybe you didn't know, that ice melts at 0 degrees Celsius. So we can just redraw this curve down here at 0 degrees. So ice can actually get colder than 0 degrees. Okay, it can get much colder. And perhaps if you stuck it on liquid nitrogen or something like that, you'd get ice that was actually colder than 0 degrees Celsius. And it's going to take a while to melt. Okay, you're adding heat, adding heat, adding heat, so that's melting. And then at some point it turns into liquid water. And then if you leave it out long enough, all of the ice will melt, and then that'll turn into water. It'll turn into pure water. And conversely, you can go the opposite direction as well. Just like with condensation and vaporization, this is the curve for, we call this fusion. Here, I'll circle it right there. That's freezing, melting. Freezing / melting. And that's called delta H of fusion. Delta H of fusion. And there's only one number. So for freezing, we use a, well, if it's freezing, we're going to use a positive because it's losing energy. And for melting, we're going to use a positive. Okay, and for freezing we use a negative because it's losing energy. All right, so I'll show you how that looks right now. We'll go back up here. Okay, so the heat of fusion is simply the energy required to turn 1 gram of liquid water into solid water, okay, or ice. The units also are joules per grams. Okay, delta H of fusion for water, delta H of fusion, water, H2O is 334 joules per gram. Okay, let's go ahead and write out the chemical formula. Well, not the chemical formula. Let's write out the just the formula, what it looks like. Okay, so we've got melting. We've got solid H2O turns into liquid H2O. Okay, and where do we put heat? Well, we know we add heat right here to solid H2O, right? That's what that looks like. Delta H is going to be positive delta H of fusion. Okay, it's going to be the positive delta H of fusion. Why positive? Because we're adding heat. Okay, let's look at freezing. In freezing, we've got H2O liquid turns into H2O solid, right? That's freezing. That's a freezing process. Okay, now where do I add heat in this situation? Well, I'm not going to add it to the liquid side, because if I added it to the liquid side, I would get boiling, right? So that doesn't make any sense. I would add it over here. I'm losing heat. And your delta, if you're losing heat, your delta H is going to be negative delta H of fusion. Okay, so it's going to be negative 334 if I'm using it in a problem that asks you to calculate how much energy was required to freeze some water, I'm going to use the negative value here. And again, why am I using the negative value? Because I'm losing energy. When I go from liquid to solid, I lose energy. That's why I'm using the negative value here. If I'm going from solid to liquid, just follow this, I'm actually adding energy. So that's why this delta H is positive. In the next video, I'm going to show you how to solve some of these problems.